Hi guys, Mr. Lupos, U1A6 homework assignment for the grade 12 advanced functions course online. I was asked to answer a couple questions. I cut and paste some of the questions here. Some of the font got a little messed up. This should be x cubed, x squared here. So this question here, the first guy here is, for what values of k does this function give the same remainder when divided by this and by this, x minus 1 and x plus 2? And the answer here is k is equal to 3. I'm kind of cheating here, but what I want to do is find out when the remainders are the same. So what's going to happen is, if the remainders are the same, well, to find the remainder of f at when I divide by this, that's the same as asking what f at 1 is. So when I go through this, I get x cubed plus 6x squared plus k at x, or kx, sorry, minus 4. I'm going to set this equal for f at 1 and f at minus 2, because my factors here were minus 1 and plus 2. And so what my roots will then be change the sign here to plus 1 and change this to minus 2. So I'm going to have this function and set them equal to each other. So I have on one side this replace f at 1, so all the x's replaced by 1. So I have 1 cubed plus 6 times 1 squared plus k1. And you could jump through this and clean this up as you do it, like k1. There's no reason to write that. You can just write k. And on the other side, you're going to have minus 2 cubed plus 6 times minus 2 squared plus k minus 2, or minus 2k minus 4. Clean this up. That's 1 plus 6 plus k minus 4 is equal to 2 times 2 times 2, negative 8. Be careful with your signs here. 2 times minus 2 is 4, times 6 is plus 24. So the negatives get taken out with the square. This is minus 2k minus 4. So I'll clean both sides up, collect like terms. 7 is minus 4 is 3, so k plus 3 on this side. And this side here, I have my minus 2k. And I have minus 12 plus 24 will get me my plus 12. Bring the k's to this side, add 2k to both sides, that's 3k. Bring the 3 over to this side, that'll be 12 minus 3, 9, and solve for k is equal to 3. Okay, so that's how you answer that question. All right, next up, rectangular shipping container. This one's a good question. Some wording issues here. When we're talking about a container, its length, it's a shipping container, and it's rectangular. Okay, so rectangular shipping container is rectangular base prism shipping container has this cubic volume. Now they go ahead and we talk about length and width and height, or length and height and width, but they use the terms width, depth, and tall or taller. Okay, and that's not a big deal. We just got to be careful here when we set things up, just so we don't mess anything up. But we'll start off with w, or width. So we'll let x, and you could use w if you wanted for width, but that could get confusing. So sorry, actually, I'm not gonna do width. I'm gonna look at this here and say this is 4 times as wide as deep. So if I'm gonna let x represent my depth, okay, and you don't need to do that. You can say let x represent one dimension if you feel like it. And if you mess up, if you start noticing there are fractions in your equations and you don't want to deal with fractions, there's nothing wrong with fractions, but they often make things more complicated. If you don't want to deal with them, go back and change things up. The best thing to do is to see if you can figure out what the smallest dimension is going to be. So if it starts here and says 4 times as wide as deep, and then so it's wider than it is deep, and then it talks about being taller than it is wide. Well, deep is smaller than wide, taller is smaller than, or bigger than wide, so deep's the smallest. Okay, and if you didn't work that out, no big deal. Let x represent the depth, and then when you go through it, then you want to talk about width. So you're going to have a couple of equations here. So let w, or sorry, not let. You want to look at the width. The width here will be w, and you could say let w represent the width if you want. And w is equal to 4 times the depth, which is 4 times x. And then finally you have what we call how tall it is, or the height, and you can call it t if you want, and that's equal to 4x plus 5 because it is 5 wide, 5 taller than it is wide. So it's 4x wide, and then it's 5 bigger than that. So my dimensions are x, 4x, and 4x plus 5. So when you multiply them, it doesn't matter, like I said, if you call length with height or whatever, but I know that I'm going to multiply x times 4x plus 5. And that is going to be equal to 2,500. So I was doing this with my grade 11s today. When you have something like this and they're not equal to each other, it's not equal to 0, you need to expand and then rearrange. Okay, sorry, my pen just died. I forgot where I was. So I set this up like this, and what I'm going to do is rearrange this eventually. So I'm going to expand here, and this is going to be 4x squared, and then 4x squared times 4x is going to be 16x cubed, and then 4x squared times 5 is going to give me plus 20x squared is equal to 2,500, but I'm going to bring the 2,500 over like this and set that equal to 0. Then I'm going to look at all this stuff and say, where's this true? What values of x makes this true? When do I have this equal to 0? And then I would just go through a process of subbing in f at various function numbers here to figure out when is this equal to 0. And if I put in 1, for example, I will not have this to be true, so that's not true. F at 2, I don't need to try any negative numbers, right? Because I can't have negative dimensions, right? I don't think I can, at least not in this question. So 1, 2, and then you get to, you notice here I have 2,500. A nice safe bet is if you're ending in 0 or 5, after trying 2 is a great guess for everything, but you go ahead and throw 5 in and see what happens. And when you do find, you do figure out that 6 times 5 cubed plus 25 squared minus 2,500 is 0. So one of your dimensions is 5. That'll be your x, which is your depth. So there's one dimension. The other one is your width, which is 4 times 5, which is 20. And then add 5 more to that. And then just to be careful, 5 times this is 1,000 times this is 25,000. Or sorry, 5 times this is 100 times this is 2,500. And that's the answer that I had in the first place. Okay, so just check that out there. That's your classic width, depth, height scenario. And then we're going to move on here. What happened here? We'll try our third question. See what's going on here. If I can get this to move down. Give me a second. Bell's about to go in my class, so I might get loud. So I have is x cubed. So this is x cubed minus 13x minus 12 divisible by this. And explain your answer. And is it divisible by that? And the truth is, we haven't done something like this before, but you can divide. There's two ways to do it, really. You could go ahead and factor this out and figure out what the factors of this is and divide both of them into here. So I could look at this and say, what's f at? So the factors of x squared minus x minus 12 are x plus 4 and minus plus 3 and x minus 4. If I go ahead and find f at negative 3, that would get me 3 cubed minus 13 times 3 minus 12. That's an ugly 13. And that's what? 27 minus 39 minus 12, and that's 0. Okay, so there's 1. And then if I go ahead and I try f at 4 for my second factor, you're going to get 4 times 4 times 4, 4 cubed, which is what? 1664. 64 minus 13 times 4. Now, I got to be careful with my signs here. I think I messed my signs up on everything. What did I do here previously? What did I do? It all worked out, though. If you mess up enough, but life. No, I'm just kidding. So that's that. That's what happened. Okay, minus 27 plus 39 minus 12. So that worked out. This is then what? 2652 minus 12. So 64 minus 52 minus 12 is 0. So that's one way to do it. Okay, find the factors of this. If both factors divide into this, then this will divide into that. Another way to do it is to use long division, and I'll add an extra page here. And this is long division a little differently than we've done it in the past, but you can probably work this out. I want to know if this divides into this. Okay, and I'm leaving a big space here on purpose. And what I'm going to do is use long division. Okay, and just got to be careful here. I don't have any x squareds, so I want to make sure that that's the case. And I put 0 x squared. You can put plus or minus, it won't matter. And I look here and I say, how do I divide this? Well, I ask myself, what times x squared gets me x cubed, and it'll be x. So then I multiply everything by x, and that will give me 1x, or I'll just write it like this, 1x squared, negative 1x squared, and this will then be minus 12x. I subtract, be careful, you subtract, just like in the old days, right? When you said, hey, is 6 going to 30, or let's say 82, you go 1, 6, and then you subtract here, right? And same with this, oh, that's wrong. You subtract 8 minus 6 is plus 2. Here you subtract, that turns into 0, or just don't write it down. This is subtract, so it's plus x squared, or plus 1x squared. This is subtract, so it's minus 13 plus 12 is minus x minus 12. And lo and behold, that is this. So if I say, how many times does x squared go into x squared? It's 1. And then everything just kind of goes from there. And when you look at it, there's no remainder. Okay, same with the other one. You want no remainder. If it divides properly, there's no remainder. Okay, hopefully that helped. Any more questions? This is a response to an email that I got. Any more questions, send me an email and I'll make a video. Thanks, take care.